So today's mission is really, really cool. We are launching NASA's Transiting Exoplanet Survey Satellite, or TESS. This is a mission that's operated by MIT, managed by NASA's Goddard Space Flight Center, and is the second launch that SpaceX has conducted for NASA's Launch Services Program. And at just 365 kilograms and just under 5 feet tall, TESS may be small, but it is doing big things. This Planet Hunter is an orbital observatory that will discover thousands of planets by monitoring over 200,000 stars in nearby planet systems, or star systems. Its science instrument is comprised of 4 high-tech, wide field of view cameras designed and manufactured by MIT's Lincoln Laboratory. These cameras will allow TESS to detect exoplanets, which are planets that are outside of our solar system. It does this by looking for a phenomenon known as a transit. This is where a planet passes in front of its host star, causing a periodic dip in that star's brightness. This allows scientists to assess the size, mass, atmospheric composition, and structure of those planets. And this is particularly exciting to astrophysicists and astrobiologists because some of those planets may fall into what is referred to as the habitable zone. That means it might have the right conditions to sustain liquid water and potentially support life. Falcon 9 will be injecting TESS into an elliptical high Earth orbit that at its highest point reaches 273,000 kilometers. That's over 2/3 of the way to our moon. After TESS separates from Falcon 9 over the next 60 days, the spacecraft will use its onboard thrusters to perform a series of maneuvers, which includes a flyby of the moon in order to slingshot it into its final high Earth science orbit. This orbit is what's going to give TESS an unobstructed view of the night sky, allowing the spacecraft to observe and catalog thousands of exoplanets for future studies by the James Webb Space Telescope, the Hubble Space Telescope, and large ground-based observatories.
Internal sequences have started.
All right, we are about 4 minutes and 45 seconds away from liftoff. So let's check in on the rocket one more time before stepping into the terminal count. Fuel is fully loaded on both stages, and liquid oxygen is being topped off right now as we speak. The rocket is also now pressurizing itself with helium gas. We use that gas in order to maintain the structural strength of the rocket while on the ground and in flight. And very soon what you're going to see is those cradle arms that are holding the rocket. They're going to open up, and the transporter erector is going to lean back slightly. It's going to retract. You also might see some venting coming from the side of from the TE. That's totally normal. It's just liquid oxygen that's boiling off, heating up, and being released from the tanks. At T-minus 1 minute, the rocket's internal flight computers are going to take over, which you'll hear on the countdown net as Falcon 9 is in startup. The range is currently looking good for an on-time launch today. The payload is healthy on internal power and is go, and weather is go. We are looking awesome for a 6:51 p.m. T0. Now, our launch window today is only 30 seconds long, but that's pretty much an instantaneous window. If for some reason we can't get off today, we'll come back again tomorrow at 7:09 p.m. Eastern Time to give it another go. So with that, let's listen in to the last 3.5 minutes of terminal count.
Startup is at retract angle 88.3 degrees.
Verification. Stage 1 lock cell complete. Manifold secured. Stage 2, lock slow complete. Falcon 9 is on internal power. Vehicles and self-line.
Ground gas closeouts is starting.
AFTS is ready for launch.
Falcon 9's in startup.
Ground gas closeouts is complete.
Stage 2, pressing for flight.
LD, go for launch.
Stage 1 is at startup pressures.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
Stage 1 propulsion is nominal.
As you just saw, Falcon 9 has successfully cleared the pad and is now on its ascent with the test spacecraft in its fairing. Now, coming up in about 15 minutes, you're going to hear the call out that Falcon 9 will have hit max Q. That stands for maximum aerodynamic pressure. That is the point at which the rocket is seeing its highest stresses on its ascent.
Vehicle has passed maximum aerodynamic pressure.
You can tell by the cheers and what you heard on that call out, we have gotten through max Q. Coming up next, you're going to hear the call for invac
Back engine chill has begun.
and that was it. That is where we chill in that Merlin vacuum engine down to operating temperature. Now, coming up here shortly, you're going to hear 3 big events happening in rapid succession. The first is MECO, that stands for main engine cutoff. That is where all 9 of the first stage engines are going to shut down. That's in preparation for the next step, which is stage sep, or stage separation. That is where stage 1 will separate from stage 2. Stage 1 will make its way back down to the drone ship. Stage 2 will continue on with tests to its orbit. And then you're going to hear second engine start. That is the ignition of the second stage engine. Let's check it out here.